Hi, my name is Neha Nair, and today we'll be going through a project for the problem statement of enhancing OpenAI's GPT-OSS with multimodal vision capabilities extensible to ISRO EO data description. Now, the core problem is that the OpenAI's powerful GPT-OSS language models are text only and cannot process or reason over images. This limitation prevents the use for analyzing visual information, such as ISRO's EO data. Our project aims to solve this by augmenting GPT-OSS with visual perception and specializing it for EO data analysis and interpretation, bridging the gap between raw satellite images and decision makers. Now, the technical challenge here that we face is that, as I said, GPT-OSS excels at text analysis but cannot process image or visual satellite data. ISRO's need sophisticated analysis for Earth observation imagery requires domain expertise. And the gap is that there is no integrated system between this, and that is what our proposed solution is. Now, our solution architect, as I mentioned, will have three components. First is GPT-OSS language brain. So we will be using the GPT-OSS model for text analysis, obviously, because that is the model that has been trained to analyze text related to this. Then comes the vision encoder, advanced computer vision module trained to interpret satellite imagery and extract meaningful features. Lightweight projection layer seamlessly bridges visual understanding with language processing for unified analysis. So these three will be the main core structure for our solution architecture. Moving on, the three-phase training strategy. Now, the phase one will obviously be the general vision training, foundation training on diverse imagery to establish robust visual understanding capabilities so that we understand the analysis for various images. Then comes the phase two, integration and alignment, connecting vision and language components through sophisticated alignment techniques, because that is where our solution stands out, is that we're bridging the gap between visual and model of text analysis. So that is what we're doing. And then comes the phase three, domain specific fine tuning. Now, specialized training on ISRO satellite data, because that is who are the domain specific customers of this project. Now comes the technical capabilities. Now, technical capabilities will be two, advanced image analysis and intelligent insights. First, we'll have to analyze the image that exists. If we understand the image very well, then it will be easier for us to perform analysis on it. But if we are not able to correctly analyze the image, then the analysis or insights will be irrelevant. So those are the two technical capabilities that are very important. So multispectral satellite data interpretation, real-time change detection algorithms, automated feature extraction and classification, temporal analysis for trend identification. And in intelligent insights, we'll be using natural language query processing, contextual explanation generation, and cross-referencing with historical data to test and train our data. Now, after this comes a demonstration overview. Now, I'll be going through the basic idea of our project and how it will look to the user. So, as you can see here, I'll minimize it out. This will be the example dashboard. Now, this is a generated image. This is just an example of how our dashboard will look. But so there will be three steps that we need to do. First, we'll upload the satellite imagery. We'll be uploading it to the dashboard. Basically, the doctor, scientist, whoever is looking forward to gain insights through the image, they won't sit and go through each and every image to understand minute little details, but the algorithm can do that for them easily within seconds. So upload the satellite imagery, then natural language queries, ask complex queries in natural language, and then instant expert analysis will be given through the output. Now, moving on to the use case application. Now, there are four main use case applications of this project. It can be used for agriculture monitoring, like analysis of crop health, predict yields, and optimize resource allocation. Disaster management, urban planning for expansion, monitoring of infrastructure development, and environmental conservation. This is a very key part. Track biodiversity changes, monitor deforestation, and support conservation efforts. Now, moving on, what will be the key deliverables and vision of this project? Now, there are four key deliverables. First is enhanced GPT-OSS model for fully integrated vision language system optimized for Earth observation applications. So we will be optimizing the GPT-OSS model so that it is advanced enough to even understand visual data. Then comes ISRO-specific training dataset, because those will be the main consumers of this project. Then comes user-friendly interface, because that is a very key part. We are trying to make things easy for the customer to use. And then comprehensive documentation for best practices for system deployment. Moving on, what will be the impact and future potential? So coming on to impact, accelerated Earth observation analysis is the first impact of this project. Reduce dependency on manual interpretation, because it takes a lot of time manually done. and enhance decision-making capabilities. And for long-term vision, I think for long-term vision, this project can really stand out for next generation space technology as a foundation because this can help India's position to better for global EO research, and this can become a platform for international collaboration as well. So thank you. This is what our project is, and me and my team will make sure that we give our best to integrate the dynamics between text analysis model and visual interpretation so that ISRO can easily process their vast Earth observation data with ease. Thank you.